Hi guys, welcome back to my channel. I'm Tatiana and this channel is about data science, data analytics and career in tech. In today's video I will do some very scientific things. I will show you how to calculate confidence intervals into Python notebook in Python. So join me to learn more about scientific approaches and apply statistical models, statistical techniques to your data, to your business, etc. Let's go. Do you know what confidence interval is? Confidence interval is a range or boundaries about a parameter or statistic that is supported mathematically with a certain level of significance. Simplifying the term of level of significance, this is something that is associated with the arrow of finding the variable, the parameter somewhere else beyond this interval. So for example, in 95% you are sure that you will find the parameter within this range. This is interval. That's why this is called confidence interval. Today I will need two packages in Python. The first one is NumPy, and I would like to import it right now. Import NumPy as np, and another package that I need today is SciPy, and exactly it's package stats. I imported my packages and then we can go ahead. Let's consider normal distribution and the sample from normal distribution. NumPy random seed, for example 0. This is my random seed for today. If you will use exactly the same seed, you will get exactly the same results as me. And now I would like to generate actually some sample from normal distribution. To do it, I need to apply stats dot norm dot, and here I should put in the brackets the mean value and the standard deviation. So let it be 0 and 1. Let it be a standard normal distribution. To actually generate it, I need to also use the function reverse, and here I put a size of sample that I need, for example 1. And here we go, I got exactly one value of my sample. I want more and I get it through increasing the number in the brackets. Let it be sample A. I outputted the first 5 items in this sample. The confidence interval has the following boundaries. So it is estimate plus minus multiplier times standard error. And estimate and standard error are defined by particular sample, about particular population. Estimate is the average of items, and standard error is a standard deviation divided by square root of number of observations in our sample. And our estimate equals something close to 0. And this is really nice because remember, we got this sample from standard normal distribution, which has a mean of 0. So let's go ahead and calculate other things. For example, I'll show you how to type down standard deviation. It will be simply numpy.std of sample, and let's see what is it. It is equals to approximately 1. Yeah, it again corresponds to our initial parameters in the distribution where we get sample. Alright, and then I would like to get the formula for standard error, which is standard error is this one divided by a square root, again numpy, of len, which is length of sample A, and see what does it mean for this. standard error. It is 0.1 approximately. Okay, now we have the most interesting part, which is multiplier. I'm calculating confidence interval for a sample mean, and the sample mean has a normal distribution itself. So for this particular sample mean, I need to get the multiplier that corresponds to some value from a table of a normal distribution. But to be honest, I don't need a table. I can just grab some function right in Python. Stats, again this module, stats distributions dot norm dot point probability point function. And I'm going to set significance level as 5%, as I have a symmetric normal distribution. I have the 2.0% from left side and 2.5% from the right side. In the middle between those two percents, I will have exactly what I need my interval, the confidence interval, the range, beyond which I am targeted only 5% of other possible observations. This is why I put here 2.5%, and this is approximately minus 1.96. And I don't need this, I need this absolute. So I get Epps number of this expression. This is plus 1.96. And we are ready to get everything in one expression. And I got an awesome interval that is identified through its boundaries of this tuple. This is a confidence interval for a sample mean. And remember that sample was generated randomly using normal distribution. In today's video, I showed you how to calculate confidence interval for a sample mean, but there are also possible solutions which are similar to this one, solutions related to confidence intervals of proportions, of difference between sample means, etc. And I hope to cover them in further videos. Thank you for watching the entire video. I hope it was very useful for you. Please show me that you like this video through pressing the like button. Don't forget to subscribe to this channel. This is how you can get more videos of the similar topics and be easily introduced to the world of statistics, science and analytics. See you in next videos. Bye bye!